Well, greetings, Mr. Kolazar's class. We're going to start out looking at today into our potential energy diagrams. Now, a potential energy diagram is a diagram that we can plot the energy of a reaction versus the time in progress. So our x-axis will be the time. It's going to be on the bottom. It's just going to be our beginning to the end of how much time it needed to take place versus the amount of energy that is needed for the reaction to take place. Chemicals have a certain amount of energy needed just for those chemical bonds to occur. So they have a certain amount of energy to begin with, and we're going to see how that energy changes as we're going along. Now, to begin with, our potential energy diagram, one of the versions, what we're looking at is we have our reactants to begin with, and then from our reactants, if we have enough energy for them to collide in the correct orientation to form that activated complex, they'll come together, and then very quickly, if this can happen, they're going to move into their products. And then as they form their new products, a certain amount of energy is going to be released. And we're going to look at investigating that information, beginning with just a little bit of information on our graph. So our first part, wherever we start at, is going to the PE, which is potential energy of our reactants. So there's a certain amount of energy that exists in the chemical bonds of our reactants. Now, from there, if we gain enough energy, we get to the potential energy of what we're going to call our activated complex, which would be when the two molecules or compounds coming close enough together where those electron orbitals can overlap, and then we can have that chemical reaction begin to take place. Now when they get here, they're going to either quickly move back down, or they're going to quickly move to our completion of a reaction. Our next line, the potential energy of the products, how much energy that they have after the reaction has taken place. The difference between our starting point and the potential energy of the activated complex is our activation energy. The activation energy is the energy needed for this reaction to start. So you always need a certain amount of energy in order for a reaction to begin. The heat of reaction is the difference from your starting point to your finishing point, how much energy was actually going to be released during this reaction. Now remember, a certain amount of energy has to go in, and then a certain amount of energy comes out. So it's the difference from your starting to your ending point. There's also a dotted line. That dotted line we'd like to add a little extra information in. Now this wasn't included in your notes, but just to put in, with the catalyst is what this dotted line says here, and the idea is that's going to be changing the amount of energy or potential energy for the activated complex. That'll be coming up in the next chapter, but we'll want to start seeing that dotted line now. So from our terms there, our activation energy, this is the top of page 3. Activation energy, minimum amount of energy required by the reacting particles in order to form the activated complex to lead to the reaction. So we need a certain amount of energy to go in order for this to happen. The activated complex is that temporary unstable arrangement of the reacting particles that can break apart and reform either the reactants or products. So that's going to be the part when we start to form our new products when those chemicals come together. So that's the beginning of our potential energy diagrams. We'll continue to look at them over the next few days.